This proof of concept. The idea of this mini demo is to show you the capabilities of this repository. So basically the architecture behind this idea is we have a simulated, well, I built a simulated device, but in general you will have a IoT device or similar, which already has some business logic on it. So in this case, just to simplify things, and avoid frictions and, keep simple things, let's say that we have a simulated device that right now is a telemetry device. It's only collecting, weather data, like kind of wind speed, temperature, humidity, these kind of things, and store that data in a local file, in an interval of every 5 seconds or every second. So basically it's storing that. Also, we have some settings, which is a different local file, in which we store the threshold, of the minimum temperature and the maximum temperature that we are expecting, So if the temperature is higher or lower than the expected, then we have some kind of alert. So also it's going to store that alert. The idea of us for this communicator will be like kind of read and write those files. So basically read the files and send the telemetry back to Azure IoT Hub. So basically the idea is you use the sensor or simulated sensors to store the wind speed. We have that in the local file. The communicator access to that file once in a while and send this information as telemetry to Azure IoT Hub. Then we have also some settings to change, right? So we have a digital twin, which is the digital representation of the device. And in the digital twin, we have the threshold of the minimum temperature and maximum temperature as well. So the idea is we can change that properties on Azure IoT Hub and send the information back to the communicator. So the communicator will be subscribed to this kind of property changes, and when it recognizes these property changes, basically it's going to overwrite the local files where we store those threshold, and the simulated device, every time that is collecting this data, is checking what are the settings. So it will be easy to see if the threshold has been updated. So in order to avoid as much as possible the manipulation, and the changes on a legacy system, which is this simulated device, the idea is this communicator is a fully separate piece. It's a different Nodejs process. It has no relationship directly with the simulated device. So the simulated device even can be, wrote in a different code language, can be a legacy C application, can be, many ways. So the idea in the communicator basically is that we are going to collect that kind of information from the local file, so there is no relationship. And in order to make both things work, we use PM2. PM2 is a process management tool. It's known from many years. It's a very good solution when you want to run some Node.js processes. So the idea is we rise both processes together. And the good thing is from the communicator, we can use child process in Node, which is a native library, to control PM2 actions. So for example, we can say like, look, from the Azure IoT Hub, I want to send a command and say like, look, I want to stop the simulated device. So we basically send this information from Azure IoT Hub to the communicator. The communicator will collect this information and will act on behalf. So basically we'll say like, look, rise a child process, exit a child process, and execute this command, like PM2 stop simulated device. And it's going to stop the simulated device, and the same when you start it or you restart it, and so on. That's the idea. Obviously PM2 can be replaced by any other tool, and the same way local files communication can be replaced by any other kind of approach. So if you have a simulated if you have a device that it's capable of doing WebSocket or HTTP communication or webhooks or any other way, you can have it. So the thing is, if your device already has some kind of API that we can use, in case that not, worst case scenario, always you can use local files. So that's an easy way to control this. Aside of that, also I added some extra capabilities. So for example, Azure IoT Hub also has the capability of sending messages to the device. So in case that you send any kind of message, you will see that also on the logs of the communicator. I added as well another extra feature, which is from the communicator to Azure IoT Hub, sending a file. In the next minute, you're going to see some demos about the command executions and about the how we modify the files and read the properties and send the telemetry and so on, just to give you an idea of this project. It's very important for you to be kind of familiar with the Azure IoT Hub behavior, so you are aware of what is a digital twin and how to use, and also the SDK. Any SDK from the Azure IoT Hub will be enough to have this knowledge, but in our case we use Nodejs. But yeah, it's kind of a very universal SDK, so in other languages you have a similar behavior, so it's not as super required to understand Node.js for follow this example. Yeah, so let's go ahead with the Azure IoT demo. Aside of that, I use Azure IoT Explorer, which is a fantastic solution, just to debug and play around and see the messages and the properties and all of that. So I will show you that in a moment. To have the instructions on how to set up all of these machines and the secrets and all of that on the README, you only need one secret for running the device, and you only need an additional secret if you want to use the Azure IoT Explorer. First thing is to control and price the project. So once you clone it and you follow the instructions, one of the most useful commands is to do like npm run machine start. So basically, this will be very useful because you can see how this behaves. So you have both parts. You have the communicator and the IoT device. You have both processes running. If you want to stop them, you just need to do a stop, and that's it. If you want to reset them, you can restart them, and when you finish, you can do like a clean, and you will just clean up. So you remove the processes from the background. The next important thing is when you start the process, also you have a log inside, so you can check it out the logger. You have here the data file. So here is, for example, where the data is stored every time, and also you have the settings here. So here the good thing is, like, when you access to using Azure IoT Explorer, you access to the device and you want to see the telemetry, for example. So in this case, I will start, and I hope soon to start receiving the telemetry points. So as you can see, I'm start receiving the values that has at that moment specifically. So the way that we store the values is with a higher frequency than the way that we send them to the cloud. So I think it's like every second we store the values, and every 5 seconds we send them to the cloud. But basically that's the idea. You get the wind speed, the temperature, the humidity. So this is the part, and in some cases you have the alert. So when it's out of the range, you will know, and that's the way you can receive this kind of information. Aside of that, you have the direct methods. So you can start, stop things. So let me show you. If you do PM2 status, you can see what's going on. So both processes are online, and if I say, like, look, send me a stop message. So the idea, if you invoke the method, you will get a status 200 response, so that's a valid, and if we check out again the status, you see that the one is stopped. That's the good thing of this architecture, that you decouple the communicator from the IoT device itself. So basically it has a different life cycle. So from the communicator, as we use PM2 with the child processes, we can control the life of the IoT device. So that's a good idea. And also you can just start it again when you want, or you can restart it. Obviously, you can extend that by adding payloads. That's a very good option also to send information. And you can also change information on the device twin. So let me show you. You have these settings right now here, like the minimum temperature and the max temperature. So let me change this a little bit. So let's say that my desired state, what I want to happen on the device, is the minimum temperature is going to be 25, and the maximum temperature in this case will be like 27.3, for example. And I just save that. So basically send the information back, and you can see here that we already override the settings of the device. So in the next interval, when it's going to store the values, you will see that information, with the alert or no alert. Basically, that's how we use it. So we change the property on the device twin, and we send the information back through the communicator, and from the communicator to the file. So that's the idea. You can have a lot of control as well. You can send the cloud to device messages, so you can send any kind of messages with additional properties and so on, and you will basically collect that from the log. As well, we have some additional command that will push files back to the Azure IoT Cloud, exactly the logger basically. So yeah, that's a very basic demo on how you can decouple both things, but that's the idea. I hope you enjoyed the demo and have a nice day.